Morning, students. Thanks to all of you for watching my previous videos and giving it a thumbs up like. And I'm really happy to have such kind of appreciation from my students. Thanks a lot. The next topic that I'm taking is area of parallelogram and triangle. The first of all, the theorem that we prove in this is the two parallelogram on the same base and between the same parallel, they are equal in area. As you can see in the diagram, we have A, B, C, D and P, Q, C, D. If you see, they are on the same base DC, and between the parallel lines, you can see PB and DC. So here we have to prove that the area of parallelogram, this is PBCD, this is equal to area of parallelogram PQCD. Now here, if you see that we'll be doing this theorem by, you can say, by our usual way. We are not doing it in a, you can say, in a proof way. We are not proving the theorem. We are just doing it by the way we were used to do in class 6th by using counting the squares. So that is just, you can say, a sort of an activity. So here, area of, if you see this PQ, so we have to prove that area of parallelogram ABCD, this is equal to area of parallelogram PQCD. Now we'll start from area of triangle parallelogram PQCD. This is equal to, as you can see, this is equal to area of triangle ADP plus area of parallelogram, it's not a parallelogram, sorry, and this is quadrilateral AQCB. Now here I'm talking of this quadrilateral. Now if you see area of triangle ADP, this is equal to area of triangle BCQ. If you see actually in the graph paper, the number of squares which lie in this triangle PAB and triangle QBC, they are exactly the same. So if I take a cutout of this triangle, this will exactly overlap this. If you see in previous video, I have told you how the congruency of the triangle take place, how two congruent triangles are, they behave. The two triangles which are congruent, they are equal in area as well. So here if you see the number of squares, they are same. If we count it physically, they are exactly the same. So area of triangle ADP is equal to area of triangle BCQ. Now here what I'm going to do is, let this equation be 1. I'll replace this area of triangle ADP by area of triangle BCQ. Let it be equation number 2. So from 1 and 2 we can write that area of, this is a, you can write area of parallelogram PQCD, area of triangle ADP, will replace it by area of triangle BCQ, area of triangle BCQ plus area of quadrilateral AQC. This is area of quadrilateral AQCD. It's not AQCB. So sorry for the mistake. This is AQCD. So if you see area of triangle BCQ, area of triangle AQCD, the total, this forms area of parallelogram ABC. So hence, whatever the theorem that we wanted to prove, that parallelogram on the same base and between the same parallel, they are equal in area. So this is what the theorem which we have done through an activity. Now the thing is, this is an activity which we generally do it in our lab, you can say math lab. Now actually if it comes like how do we prove this theorem? So in that case I must say like we'll come to the theorem. This is parallelogram on the same base and between the same parallel they are equal in area. So here first important thing, what to prove, what is our motive. We'll identify the parallelogram. This is ABCD. This is a parallelogram and the other parallelogram is EFCD. So to prove area of parallelogram, this is ABCD. ABCD. This is equal to area of parallelogram EFCD. Okay, so this is what we want to prove. If you see again in this parallelogram ABCD and EFCD, this part is common. EBCD, that is this quadrilateral is common. So you can say the only difference between these two parallelograms is these triangles. These two triangles are different in these parallelograms. So what should we do? What we will do, we'll find out whether they are equal in area or how to prove that these two triangles are equal in area. So if you see children, now the thing is here this side is parallel to this and this is a transversal. Okay, so we can apply the, you can say, the laws of parallel lines. This side is parallel to this side, so this angle will be equal to this angle, number one. Secondly, now this line is parallel to this line, so this angle will be equal to this corresponding angles. So here, and if you take triangle, we can say that angle EAD, this is equal to angle, here this angle is equal to angle FBC. Now again, now here this angle, that is angle AED, this is equal to angle BFC. So the laws will be corresponding angles. Now if you see these two triangles, if two angles are equal, third angle will be automatically equal. That is angle ADE will be equal to angle BCF by angle sum property of a triangle. Now if I compare the triangle ADE and triangle here, this is BCF. So AD is equal to BC. AD is equal to BC since they are the opposite sides of parallelogram. Opposite sides of parallelogram. Now next is angle this, that is angle EAD. This is equal to angle, you can write angle CBF. Okay, this is the second criteria. The third criteria is this, which we have just now proved, that is angle ADE. This is equal to angle BCF, earlier proved. Therefore, triangle ADE is congruent to triangle BCF by EES correspondence, congruence. So this means area of this triangle, ADE, this is equal to area of triangle BCF. Okay, now here what we will do, we'll write area of parallelogram ABCD. So area of parallelogram here, area of parallelogram ABCD, this is area of triangle ADE plus area of quadrilateral EBCD. So here we'll write area of parallelogram ABCD. This is area of triangle ADE plus area of, this is quadrilateral EBCD. Now we'll replace ADE by BCF. So area of triangle BCF plus area of quadrilateral EBCD. Now if you see the total sum, that is BCF plus EBCD, this becomes parallelogram EFCD. So area of parallelogram ABCD is equal to area of parallelogram AFCD, and hence this was our theorem which we wanted to prove, that two parallelograms on the same base and between the same parallel, they are equal in area. Now comes the third theorem. Well, after this we have an example in the NCERT, but I must say we use it extensively as a result in many of the questions. So the theorem is, or I must say the result is, if a triangle and a parallelogram, they are on the same base. Okay, so here we can see the triangle PAB and parallelogram ABCD, they are on the same base and between the same parallel. So then area of a triangle, that is PAB, this is equal to half the area of parallelogram, that is ABCD. So we have to prove that area of triangle APB is half the area of parallelogram ABCD. So here we'll write that APB and parallelogram ABCD, they are on the same base and between the same parallel. So how the proof is going to work in this case. So here we'll start like what we can do, we'll have construction. What we will do, we'll draw a line parallel to PA. This QB is drawn parallel to, this will be a construction. Draw QB parallel to PA. If you see, like this line PC was already parallel to AB, and we have constructed PA parallel to QB, and hence PQBA, it becomes a parallelogram. Now in the proof or the solution, what we will do, this is we'll write here PQ is already parallel to AB, this was given to us, and QB is parallel to PA by construction. So in a quadrilateral we have two pairs of parallel sides. This implies PQBA is a parallelogram. Now if you recall the property of parallelogram, it says that the diagonal of the parallelogram divides the triangle, divides the quadrilateral in two halves. Or here we have area of triangle, this is APP, this is equal to area of triangle, we can have BPQ, or area of triangle APB, this is half area of parallelogram ABQD. Okay, now if you recall the theorem which we did just before, The theorem was, if there are two parallelograms A, B, Q, P. This is one of the parallelogram A, B. We'll write A, B, Q, P. It's not D. Okay. So sorry for this mistake. Area of parallelogram A, B, Q, P and parallelogram A, B, C, D. They are equal in area. Now the thing is, we need to identify the parallelogram which are on the same base and between the same parallel. So here parallelogram A, B, C, D and parallelogram A, B, Q, D are on the same base AB, same base AB, and between the parallel AB and BC. So therefore these two parallelograms are equal in area. So area of parallelogram A, B, C, D, this is equal to area of parallelogram A, B, Q, P. Area of parallelogram A, B, Q, P. Now here what we will do, I'll replace area of this, I'll replace A, B, Q, P by area of parallelogram A, B, C, D, because A, B, Q, P is the parallelogram which we have constructed. This was not in the, you can say, question. So here we'll replace it here in this equation. Let it this equation be 1, this be 2. So here what we will write, area of triangle APB is equal to half area of parallelogram ABCD. So I'll replace from 1 and 2. From 1 and 2, write area of, this is triangle APB, this is half area of parallelogram, this is ABCD. Area of parallelogram ABCD, hence root. So I must say, just go through the theorems, and in the next upcoming video I'll be taking questions based on all these theorems. Thank you and have a nice day. Thanks. Please like the video, share it, and do comment. Thank you.